Hello, welcome to the TechnoVersions shop. This is where we build all of our products. My name is Brian, and today I'm going to tell you about our tachometer tester, the model TT-01. We're going to unpackage one to show you what you get, and then I'll explain a little bit about it, and then we'll use it to test some of these various tachometers around here. So let's get started. It's in a box like this. The instruction manual on the top. In the instruction manual, you'll find the things that we talked about today, plus a lot of other detail that will help you once you get the unit. Also in the box is a set of cables. These are nice, flexible alligator clip cables, 1 meter long. It's about 3 feet on each color that we use. Also in the box, you'll find a charger. And finally, the tachometer tester itself. During shipment, this bridge is installed just to make sure that the power switch doesn't turn on during the shipment process. All right, I'll put some of this stuff off to the side, make a little more room here. Okay. So the tachometer tester comes in 2 different versions. We've shipped it with in the past. One is a standard version where you plug it in a wall socket or to a wall socket, and that provides power to the unit, and you leave it plugged in all the time you're using it. The other configuration that we shipped has an internal battery, and the battery will power it for long periods of time, and that can be really handy if you want to go off and test some tachometers at a swap meet, for example. So that plugs in the same. This one happens to be installed with the battery, and it'll give you a green indicator if it's charged. Otherwise, you should charge it every couple of weeks. It'll turn red while it's charging, and the charge lasts a long time. Okay, there's several controls and indicators. Oh, I might mention it is a lithium-ion battery in there, so make sure if you don't use the factory charger that it is one that's made for 12-volt lithium-ion batteries. Okay, the unit itself has 2 big knobs. One of them is the RPM in thousands that you want to output to the tachometer that you're testing. It has decade steps all the way from 500 RPM and then 1,000 up to 8,000. Actually, we don't publish this, but it works at 9,000 and 10,000 RPM also for all of the outputs other than the vintage output. This knob over here is to tell the tester how many cylinders the tachometer was designed for that you're testing. So for example, if you have a 4-cylinder tachometer, you would set this to 4. The potentiometer here is used to set the calibration on vintage tachs, and it applies to this jack only. Down here we have the power on-off switch. You should have the power off all the time when you're changing connections, because that turns off the output and the voltage output here. Power tells us when we have power on, and output when the output is valid. So for example, if you have one of these knobs in an invalid position, the green light wouldn't come on. These are all standard banana jacks with 3/4 inch spacing. So for use, you'll connect the ground wire into here, the 12-volt into here, and the signal wire here. For most tachometers, you'll run across the norm position is the one that you'll be using. Most of the tachometers are that way. So let's test a tachometer. I might point out that the signal that comes out of the normal output is a 12-volt square wave, and this is typical of what you'll find out of our TachMatch and the MSD devices, and similar to what you might find from an ECU as well. It's 12 volts. It's not 50% duty cycle, but it's 12 volts peak to peak. So let's take a look at this tach first. And the signal goes into this, and power here, and ground here. Okay, so we can turn our unit on here, and there the tach rises up So we have this set at 4,000 and this set at 4 cylinders. So that must be a 4-cylinder tachometer because it's fairly close. So let's run this tachometer through its paces. Let's try it at 5,000, 6,000. It's fairly accurate. 7,000. Now it's starting to get a little bit on the high side and even higher at 8. And then if we measure down here, it's a little high at 3, a little high at 2, a little high at 1, slightly high at 0.5. Not too bad considering it's not an expensive tachometer. Okay, the next tachometer we'll test is this one here. And again, we just need power and ground out of the unit to them, and then the signal, testing signal. Okay, now we can turn this on. Okay, we can see this is 4,000 RPM we expect, but it's only 2, so we'll crank this up until it's 4,000. So it's an 8, so that means this is an 8-cylinder tach. Okay, now we'll try it. This one is just very accurate. Slightly low up there, but not much. And down here, it's very good as well. So I would consider this a better than average tachometer. Okay, so there's 2 voltage triggered tachometers. Now we're going to look at another one that's slightly different. Connect it to this one. Power ground and the signal. Okay, now turn on the tester. Nothing happens. So that's an indication that it might need the boosted signal. And there we go. Now it's working. The boosted signal, I'll show you what that is. That's typically the signal that you would get out of a coil terminal. And this was our normal 12-volt signal down here like we looked at before, but because of the inductive kick of coils, they require this additional, some tachometers require or need that additional spike that they provide. So this is what we do, and this is provided via our V-Boost module as well. You should be a little bit careful. This high voltage spike there, it's low power, but it'll give you a little bit of a tingle, so you shouldn't touch that if you don't need to. Okay, so that's our standard voltage-driven tachometers, both standard ones and ones that require a pulse. Now we'll look at another different type of tachometer. Yeah. This time, we will look at the tachometers that we refer to as vintage tachometers. I mean, some people might think all of these are vintage, and they are, but these are the really old ones. Here's an example here. This is an old Sun tach, and this type of tachometer is identified because they just have 2 terminals on the back, a plus and a minus, and they're originally driven by an interface box like this. This is a Sun EB series interface box. The Stewart-Warner tachometers like this had more of a round type can interface box. In any case, our tach match product will drive any of these tachometers, and some people choose to mount it inside the original interface. And there's instructions on the website, our website, about how to do that if you wanted to do that to keep the car looking more original. So let's connect up here. These particular tachs don't need power connected. They just need ground and the positive signal. So we connect this then for vintage tachs to the vintage terminal. Typically you want to turn that all the way down, set it to something like 4,000 RPM, which would be mid-scale on a tachometer like this. And we'll turn it on. And you can see the tachometer responded, but it's not 4,000 RPM. So we set this gain control until it reads 4,000 RPM to calibrate it. And that would be inside a tach match if we're using that to drive it. Now we can try it at different RPMs, 5,000, 6,000, it's very close. 4,000, 3, 2, 1, 500 RPM. This is a really good tach. You don't see very many of these older tachs that are that accurate. So that's the Stewart-Warner tach. So now let's move over to this tach. Okay, so we put the green on the plus terminal and ground on the minus terminal. And turn this back down. We do that because if you have it too high, it can cause the tach to bounce at the top and put a little load on it, which we don't want to do. So turn it down, turn power on, then turn it back up. Again, 4,000 up. So now with this tachometer, let's see what we have. 5,000. It's going high. This is 6, 7, 8. So it's reading high there. Let's see how it does down here. Oops. Now it's reading low, 2,000, 1,500. So this one's low on this end of the scale and high on this end of the scale. And this is not that atypical. And these tachometers are old, they're dirty, they're 50, 60 years old, and few of them are very linear anymore. So, but the best compromise for your car probably is to choose a calibration point down low, like here, like at 2,000, somewhere in the range that you're going to be using the tachometer the most, and then it'll be the most accurate for you in real life. So that's our vintage tachometers and how to test those. We've got one more type of tachometer to look at here. And that is a current-driven tachometer. And this is an example of one here. And these can be identified typically because they have a loop of wire in the back. And so that is typically connected between the ignition switch and the coil positive. And the tachometer, via that coil, induces voltage from the current in the wire, and that causes the tach to work. So in this case, we connect, let's see, we'll connect these up. We have the here, power, and ground. There's some wiring inside this fixture, but in reality, when you hook it up just a loose one on its own, the red wire will go into the loop, and then it will come back through the green wire, which is connected to the iDrive terminal. So that's how that one works. Okay, so let's turn this one on. Okay, it's reading a little low. This is from a 240Z, an early 240Z, and so that's a 6-cylinder machine. So here's 2,000, 3,000, 4. This is a very accurate tach, particularly for one of these older ones. A little low at 7, a little low at 8, 2, 1, 5. That's really excellent. So that's how we test a current-driven tach. So this is all the types of tachometers that we can test, and it covers just about all of the bases, other than maybe some of the newest CAN-based ones that this wasn't designed to accommodate. Anyway, if you have any questions, shoot us an email. Be happy to help. Thank you for watching.